If even one reading drifts outside spec, the test stops immediately. Get the timing off by even one tooth on the drive gear, and the whole engine could destroy itself on startup. This automation doesn't just speed things up, it protects the consistency that riders count on. Camshafts are installed next, precisely timed to control exactly when each valve opens and closes. Inside the machining bay, computer-controlled tools carve the crankcase to tolerances thinner than a human hair.
So how does a company that started in a 10-by-10 wooden shed now build engines that roar across 6 continents?
Every crankshaft is balanced and inspected before it's lowered into the crankcase. The crankshaft is carefully lowered into the crankcase, aligned to a fraction of a millimeter. A single cutting head can rotate, tilt, and plunge in the same motion a human hand never could. And it's about to get a lot more precise. This is the heart of the story, where a machined block of aluminum becomes an actual engine.
It started with a single-cylinder engine, inspired by early French de Dion-Bouton design, hand-fitted to a bicycle frame.
Every bolt on this engine had a specified torque valve, hundreds of individual settings, all logged digitally. Because a Harley-Davidson engine doesn't leave this building until it's earned the right to. Every engine that passes gets a digital certificate logged permanently to its serial number. But the most incredible part of this entire process hasn't even started yet, because this is where the engine finally comes to life.
More than a century later, the philosophy hasn't changed, but almost everything else has. Some engine kits even travel further, all the way to assembly operations in Manaus, Brazil, and Bawal, India.
The engine is run through a full range of RPM, simulating everything from idle to highway speed. Before a single engine ships, it has to survive the dyno room. Here, engineers push each engine through simulated real-world conditions: throttle, load, heat, and vibration. If a customer ever reports an issue, engineers can trace that single part back to the exact machine and shift that built it. Few outsiders ever get inside these walls. Today, we do.
This is not an assembly line. This is where legends are forged, one cylinder at a time.
Today, that legacy lives inside the Pilgrim Road Powertrain Operations Facility in Menominee Falls, just outside Milwaukee. At this stage, the engine looks complete, but it hasn't proven anything yet. Modern V-twins use computer-optimized cooling, fuel injection, and counterbalancing systems that the original engineers could never have imagined. Today, we go inside the real Harley-Davidson engine plant, the machines, the metal, and the people who never let quality slip. Harley-Davidson has been building engines in the Milwaukee area since 1903, making it one of the oldest continuously running engine programs in American manufacturing.
Every single Harley-Davidson V-twin engine on Earth traces back to this one building.
So nothing moves forward until the casting earns a passing grade.
Within minutes, that liquid metal solidifies into the rough skeleton of a future engine.
That level of traceability is part of what separates a mass-market engine from a precision-built American V-twin. Machinists still oversee every station, checking programs, swapping tools, and verifying quality by hand. Every bore, every bolt hole, every oil passage is cut to a tolerance measured in thousandths of an inch. By the end of this video, you'll never look at a V-twin the same way again.
Somewhere in Wisconsin, A piece of raw aluminum is about to become the heartbeat of an American icon.
That means a motorcycle roaring down a highway in Mumbai and one cruising through Milwaukee may share the exact same engine architecture.
Connecting rods link the pistons to the crankshaft. Povia, the exact mechanism that turns explosions into motion. Pistons are fitted next, each one matched to its cylinder by exact weight and clearance specifications.
This single plant is estimated to cover somewhere between 850,000 and over 900,000 square feet, the size of roughly 15 football fields.
From here, finished powertrains are shipped to final assembly plants in York, Pennsylvania and Kansas City, Missouri.
One mistake here, and a bike worth $30,000 never leaves the factory floor.
Any engine that fails is pulled from the line and torn back down for inspection.
The casting is still rough at this stage, closer to a boulder than a finished part.
That's why robots handle the loading and unloading, reducing human error and repetitive strain. Get it wrong by even a fraction, and the entire part is scrapped.
It's a level of automation most riders will never see, hidden behind the chrome and the thunder.
These robotic cells were engineered specifically to handle the tighter tolerances of the modern Milwaukee 8 engine.
Inside, robots and master machinists work side by side to hit tolerances thinner than a human hair. Robots at Pilgrim Road don't replace workers. They take on the repetitive, high-precision tasks that never get tired. Sensors monitor oil pressure, exhaust temperature, and vibration hundreds of times per second.
This is where raw material starts becoming engineering. Bearings, seals, and oil passages are checked by hand, because touch can catch what a sensor sometimes misses. A trained ear can catch a problem a computer might miss completely. Listening booths are used to detect any unusual knocks, ticks, or vibrations invisibly to sensors. Because at some point, this engine needs human hands.
Wiring harnesses, sensors, and fuel systems are added, turning a mechanical sculpture into a fully functioning power unit.
Cylinder heads are torqued down last, sealing the combustion chambers that will fire millions of times over the engine's life.
That's why every timing step is double-checked, sometimes triple-checked, before the engine moves forward. Torque wrenches click in a very specific sequence. The wrong order can warp the entire case.
The transmission is built alongside the engine, engineered to handle the torque of a V-twin from a dead stop.
By 1909, Harley-Davidson had designed its first true V-twin, a layout so effective it still powers every big twin engine built today. That basic V-shaped layout became one of the most recognizable engine silhouettes in the world.
Inside those walls, workers machine, assemble, and test the Big Twin, the Milwaukee 8, and the Sportster engine families.
From raw aluminum to a fully tested powertrain, this journey represents one of the most demanding manufacturing processes in the industry.
It's a supply chain most riders never think about pest, but one that never stops moving.
Others will be shipped as powertrain kits, destined for assembly plants as far away as Brazil and India.
Somewhere right now, another crankcase is being lowered onto a crankshaft, starting this entire journey all over again. Harley-Davidson has also explored electric powertrains through its Livewire brand, a sign the company is thinking decades ahead.
This is the moment an engine stops being a collection of parts, Beaver, and becomes a Harley-Davidson. Every engine leaving this dock carries the same promise stamped into it a century ago. Passing the dyno is only half the battle. Visual and dimensional inspection comes next. Every part of this engine passed through human hands and machine precision, working in perfect coordination.
One weak engine, multiplied across thousands of units, could damage decades of trust.
Only after clearing every checkpoint does an engine finally earn its place in the shipping bay.
It's a brutally honest system. No engine gets special treatment, no matter how far along it is. More valves, better cooling, and smarter engineering to backsense, all while keeping that unmistakable V-twin sound.
Engineers here aren't just building engines. They're protecting a sound that means something to millions of riders.
Engineers here aren't just building engines. They're protecting a sound that means something to millions of riders.
Every engine that leaves this building carries a piece of that history forward. Finished engines and transmissions are carefully packed and shipped by truck to final assembly plants.
But even as technology evolves, the V-twin remains the emotional core of the brand.
But even as technology evolves, the V-twin remains the emotional core of the brand.
That balance between innovation and identity is what keeps this factory relevant after more than 100 years. It's a process built on more than a century of refinement, and it still isn't finished evolving.
This is the finished result, a complete Harley-Davidson V-twin, ready to be mounted into a motorcycle frame.
This is how a company protects a reputation built over more than a century.
Inspectors check for paint consistency, casting finish, and even the alignment of engraved branding.
This has been Factory Core Machines. We'll see you inside the next factory.
This is how an American icon is built. One engine, one torque click, one test at a time. From there, some bikes will roll off showroom floors right here in the United States.
To build it, Pilgrim Road spent roughly 2 years quietly upgrading machining cells before the engine ever launched.
Every future redesign will be measured against one question: does it still sound like a Harley?
If you enjoyed this behind-the-scenes look into modern manufacturing, subscribe for more incredible factory documentaries.
Random units are pulled for deeper teardown audits, a sacrifice made purely in the name of consistency.
Built in Wisconsin. Tested to the limit. Trusted around the world.
Some head to York, Pennsylvania. Others to Kansas City, Missouri, where they'll be fitted into complete motorcycles. Into this Cousins. From a 10x10 wooden shed in 1903 to a 900,000 square foot precision factory today, Murnut.
That means a single Wisconsin factory quietly powers motorcycles on nearly every continent.